In Chapter 17, we move our scale up a little bit. Chapter 16 focused on populations and the interaction of individuals within a single population and their environment. In Chapter 17, we move up to the community and the whole ecosystem level. So a community is a group of populations, a group or groups of all of the living organisms in a particular environment. Then when we get to the ecosystem level, we begin talking about all of the communities within that environment, plus all the non-living components of that environment. So the organisms not only are interacting within their own populations, they're interacting with other populations, other species, other types of organisms, and they're interacting with their environment around them. So the scale with which you look at a particular community or even an ecosystem is going to vary depending on what you're interested in. So for example, our book uses this particular beetle, and it describes a situation where there are bacteria on the outside of the beetle and there are bacteria in its gut, and there are these fantastic communities growing just within this particular beetle. But then of course you can also talk about maybe the microenvironment, the specific habitat that this beetle's in, and all of the other beetles that it interacts with and all the other insects and the plants. Then you could even get out to a larger ecosystem and say the tropical rainforest in which he lives. So we can look at different scales depending on what we're interested in. Are we interested in a very small micro ecosystem, or are we interested in what's going on in that larger ecosystem around it? There are ecosystems all over the place, and you can even look at our entire planet as an ecosystem. But there are more specific ecosystems, and we'll talk about those in just a few minutes. Those ecosystems are going to take up whole regions of our planet. And then we have even smaller environments that we can talk about. We can talk about suburban or urban ecosystems. We can talk about rural ecosystems. But no matter what ecosystem we're talking about, there are two essential features for that particular ecosystem. Now we call them a system because they are interactions of a lot of different parts. Just like we might have a mechanical system and you need to put energy in and the moving parts and the bits and pieces, ecosystems are organized the same way. And biologists monitor the different inputs, outputs, and the interactions of all of the different parts. So a biologist might look at the energy that comes in, the energy that goes out, the molecules that are transferred between organisms and between organisms and the environment. They're also going to look at the interactions between the biotic, the living part of the environment, and the physical or the abiotic, the non-living parts of the environment. So the biotic part of the environment is going to be all of the living organisms and all of the products of the living organisms. So for example, in this ecosystem here, this is a tropical water ecosystem. You have those plants on the island or the atoll in the background. There are a variety of different plants you can recognize just by looking at them. And then of course you have the fish, you have the coral, you even have plankton within that water. And then you also have those living organisms dying and decomposing. And the products of their decomposition are also considered biotic because they came from living organisms. And if you are on land, you're also, or even in the water, you're also going to have nutrients in the ground. Some of those might come from living organisms. Others might be part of the abiotic part of the environment, the chemicals, the physical conditions, the resources for that environment that are going to help feed the living part of that environment. Now, depending on what we're talking about, this might be chemicals within the soil. It might be the wind patterns. It might be the rain patterns, the temperature. So the abiotic part of the environment is going to have a strong influence on the biotic part of the environment. And then of course, if we're looking at the ecosystem, we're also looking at all the interactions of the communities within that ecosystem. So how are those fish interacting with that coral? How are the animals, the birds, the lizards, things like that on that island interacting with the plants? How are they interacting with each other? These are all of the things that as somebody is studying a community and an ecosystem that they're going to look at. So our planet is made up of approximately 9 large regions or types of ecosystems that cover our entire planet. These large ecosystems are called biomes. They're basically regions of our planet that are determined by temperature and rainfall. Now these biomes can be water or they can be land. And then depending on what chart or book you're looking at, you're going to see different types of biomes, different labels, different numbers of biomes. But our book goes into 9 terrestrial or land-based biomes and 5 aquatic or water-based biomes. Now, to some extent, these biomes are affected by the location of the equator through the center of the earth and by the poles, the top and the bottom. And they are also strongly affected by the shape of the earth. And this is because the shape of the earth affects weather patterns and it affects temperature. And because it affects weather and temperature, it also affects the rainfall patterns. And we'll see in a few minutes that these biomes are largely determined by the temperature and rainfall in a particular location. So our book gives us 9 main terrestrial biomes. Some of these you're going to be familiar with, some of them you're not. If you were standing in an area that had a huge amount of vegetation, very dense vegetation, really tall trees, climbing vines, lots of insects, humidity, rain, you could probably guess that you're in a rainforest. Here in Illinois, we're sort of on the border between or at least in the St. Louis area of Illinois, we're on the border between a temperate grassland. So as you move west across the Mississippi, you're going to move into temperate grassland. And if you go east, we're going to be temperate deciduous forest. And you can see from the pictures in the middle there, those are very different types of landscapes. Now, the reason for these vastly different types of landscapes are largely linked to the temperature and the amount of precipitation in those areas. And then even more differences come by the magnitude of the variation in those temperature differences. Each one is going to have their own specific type of temperature range, own specific amount of average annual rainfall. And then because of that, each one is largely characterized by the plants that live in that particular biome. Because plants, just like animals, are going to be specifically adapted to their environment. So if you're a plant that needs a lot of rainfall every year, you're going to do better in a tropical rainforest than you are in a desert or a chaparral region. Just like terrestrial biomes, we also have aquatic biomes. Rather than being characterized by their temperature and rainfall, they're actually more often characterized by the amount of salt in the water, how the water moves, and how deep they are. So let's talk a little bit more about these terrestrial biomes. The rainforest, you all are probably pretty familiar with that. Rainforests are generally found along the equator. And we'll talk about those why that is in just a few minutes. As you move farther north and south, you're going to get to some drier environments. So you're going to find your savanna environments, your chaparral, your grasslands, your deserts, your tundras. These are areas where you have much less rainfall. And we'll talk about how that relates to the curvature of the earth and the impact of the sun in just a few minutes. On this chart here, you can see where these regions are located. You can see desert regions. They are usually found above or below 30 degrees latitude. And that relates to the rainfall coming off of the equator. And again, we'll go into that in just a minute. If you go very far north, you're going to enter tundra. This is a very dry region, of cold, dry region, so there's not a lot of precipitation up there. A little farther south, you end up with your polar region where you have more precipitation. And then in between, we've got a variety of different types of environments. And not only are these environments affected by temperature and rainfall, but they're also to some extent affected by the geography of the area in which they are located. So if we look at the shape of the Earth, you guys all know that the Earth is round, or at least I hope you know that at this point. And we have the sun. And we have temperature differences as we go north and south. We also have seasonal differences, but we're going to talk about the overall differences in temperature. Now, if you have a basketball, let's say that this is a basketball and we have a flashlight that we're going to use as the sun. And you shine your flashlight on the line, the equator of that basketball. If you hold up a basketball, you'll see it. If you shine it directly at that line, you're going to see that the light is most intense right around that equation. The equator. And as you look farther toward either end, top or bottom of the basketball, you'll see that the light hits it less directly. Now that's because the light is hitting your basketball, or if we go back to our Earth example, hitting the Earth right at the equator, and then the light spreads out from there. Now where you have the sunlight or the flashlight most directly hitting the equator, you're going to have the most intense light. So you're going to have the most intense light and therefore the most intense heat over the small area that surrounds the equator. The light that is hitting the planet towards the poles farther up is hitting it at a steeper angle. And it's not concentrated. It's spreading its warmth out over a larger area. And so you get less intense heat the farther you move from the equator. Now, as most of you are probably familiar with the shape of the Earth and the environments, you know that if you were to start in Illinois and walk south, if you've ever visited Florida, you'll know that it gets a little bit hot the farther you go. And if you continue into Mexico, the Yucatan Peninsula, down towards South America and our rainforest, you'll know that it's going to get hotter and hotter. And it's hotter for longer during the year. Now, all of this heat affects rain, and rain, along with heat, is one of the deciding factors in which biomes we find where. So rain is produced by sunlight hitting the earth, heating up that earth, and causing warm air around it to move up. Sorry, my brain died there for a minute. The warm air is going to rise, aided by the heat from the sun. So it's going to rise from the earth. Now, when air is warm, it has the capacity to hold a lot of moisture. As that air cools, it loses its capacity to hold that moisture. So as the air rises, because warm air rises, as the air rises, it begins to cool. Now, as it cools, it loses its ability to hold the rain or the moisture in that air. When that happens, you get the liquid, the vapor, condensing into clouds. And eventually, if there's too much moisture in that air, it's going to fall back as rain because the clouds and the air can't hold that moisture anymore. So in areas where you have a lot of sunlight directly hitting the earth, you're going to have more air warming up. It's going to be hotter. So it's going to pick up the moisture from the environment around it, and it's going to rise. And then, of course, once it cools again, it's going to fall back to earth. And so that's why you have a lot of rainfall around the equator as well as high temperatures, because you've got direct sunlight coupled with the air picking up moisture and then raining it back down. Now, this same phenomenon is responsible for formations of deserts. Now, when I first looked at this chart, I found it very confusing, and in all honesty, I had to have my husband come explain it to me because it was confusing me. But let me try to explain what's going on here because it's really important for why we get deserts around 30 degrees latitude and longitude, and why we get rain around 0 degrees and 60 degrees north and south. So in the previous slide, I said that the direct sunlight, which we don't have direct sunlight showing here, but remember the direct sunlight's going to hit the equator, and we have direct sunlight hitting the equator. Now that sunlight is going to cause the land and the air to heat around it. Remember that heat rises and warm air holds a lot of moisture. So that warm air is going to be sucked up into the atmosphere. And remember, if we're making rain, that warm air is going to cool as it rises. It's going to lose its ability to hold that rain, and that rain is going to fall back down on the equator. Now, when that rain falls down, the air is actually going to spread out, either north or south. The air is going to spread out, and because it's cool, the air is going to fall back down. Now, as that air heats up, it's going to hold moisture in. So we sort of have the opposite effect of the equator, where at the equator we were picking up water and holding it in and cooling and dropping. We're now doing the opposite. Our air is falling and it's becoming warmer. Now, warm air has a higher affinity for that water. It's going to hold onto it a bit longer, and in some cases it's not going to rain it down at all. In really hot deserts and really warm air, you can actually have that warm air pulling moisture out of the land, compounding that problem of lack of rain. And then we have the opposite pattern at 60 degrees north and south. We get the rain form and then it falls, which is why we get this band of significantly drier air around 30 degrees north and south. And that's why we find deserts located in these regions. You can see there's the Sahara over there. This desert here is called the Mojave. And then we've got the Atacama, I believe, down here in South America. I might be wrong on that one. But you can see you've got deserts forming in these areas. And then there's another desert over on the other side around on the Asian side in China, over near China, in China. So not only does the temperature and the rainfall and the overall patterns of water movement and air movement affect the global positioning of our biomes, we can also have local biomes that are affected by the topography of the area. So the topography is the shape of the land. Now, mountains will create something called a rain shadow, and it's based on the same effect that we saw on the previous page with our air patterns and our formation of deserts. This picture is showing really any mountain range, but if this could be the Andes Mountain, or this image is the Andes Mountains. You also have the same effect in California with the Cascades and the Rockies, some of the mountains in Southern California. You get moist air coming off of the ocean. That's going to be warmer air, possibly warm air. And then as that warm air that's saturated with water hits the mountains are going to force it to turn upward. And as it turns upward, that air is going to cool and the rain is going to fall on the front side of the mountain range. So you can get locally concentrated rain events that's going to create a wetter environment here. And then just like our rainfall patterns on a global scale, as we reach the other side of the mountain, our air is cool, it's dropped all of its moisture. And as it falls, it begins to heat up and it holds moisture at this point. And so on this side of the mountain range, on the back side of the mountain range, you end up with something called a rain shadow. Now it's called a rain shadow because the rain is blocked by the mountains. In the backside, you get no rain. It's like blocking the sunshine. If you have a big umbrella or a big tree, you're going to create a shadow by blocking the sun. These mountains are creating a shadow by blocking the rain. Another neat phenomenon that occurs is the relationship between altitude and latitude. So as you increase in altitude, every 1,000 meters, you're going to decrease your temperature by 6 degrees. The same thing happens as you move north and south. North from the equator or south from the equator. As you begin to move farther north or south, your temperature also increases. So you might notice, if you've spent much time in the mountains or in other areas besides Illinois, you might notice that there's similar vegetation as you move up mountains and as you move farther north. And that's because the temperature difference between moving north and moving up is going to have a similar effect on the overall temperature of the environment. Now, humans can also have a strong impact on their local environment. Now, I'm not talking about global warming and things like that. I'm talking about the environment within a city or within a rural area. So things like asphalt, cement, surfaces within cities can absorb heat. Now this causes, because the buildings and things are holding in heat, they're absorbing heat from the sun, this causes the local temperature to rise. So the local temperature within a city might be a few degrees higher than the local temperature in a more suburban or rural area. Tall buildings can also channel wind. So if a gust of wind hits these buildings here, it's going to be deflected up or down. And so when that is deflected down, when the wind is deflected down off of the building, it's going to cause wind in between the buildings. So even on a day that isn't particularly windy, if you were standing in your front yard, if you're in the city, any wind that hits those buildings, and wind that's higher, maybe hitting the top of the buildings, is going to be stronger than wind down on the ground anyway. Any wind that hits those buildings is going to be deflected up or down, causing wind in the local environment below. The ocean currents can also affect the environments around the land and water environments. Now, there are major ocean currents that spin in particular fashion north and south of the equator. So if you are north of the equator, ocean currents are going to spin in a clockwise fashion. Now this causes the water to move, and with it, the temperature in the water moves as well. So as we spin clockwise, as we get closer to the equator, the water gets warmer, and that spinning motion causes the warm water to move north. Eventually it cools, and the cool water moves south. So this is why if you've ever been to Southern California, you'll know that the beaches are cold. If you haven't been to Southern California, I'm going to tell you the beaches are cold. If you want warm beaches, you need to go to the East Coast for the same reason. As the ocean current spins in the Atlantic, it draws warm water up from the equator and brings it along the eastern seaboard. As it moves farther north, it begins to cool, and so there's cool ocean currents along the western coast of Europe and Africa. Below the equator, the rotation is counterclockwise, and so you have the opposite effect. In the northern hemisphere, the western coasts are going to be colder, the water temperatures are going to be colder, and the eastern coasts are going to be warmer. But down in the southern hemisphere, the eastern coasts are going to be warmer, and the western coasts are going to be a little bit cooler.